Let's use this small microcontroller board and resistive DAC to illustrate some of the new and unique features of this 5 Series mixed signal oscilloscope. This large 15.6-inch high-resolution capacitive touchscreen has got a lot of features to make the scope easy to use. There are numeric scale indicators, both horizontally and vertically, to make it easy to determine voltages and timing without having to count divisions. Now, each of the 8 channels are all color-coded, so that the badge on the screen, the trace color, and even the illumination around the controls correspond to that color of the selected trace. So if I add channel number 2, we'll notice now that that trace is blue, as is the badge, and the colors around the vertical controls. And every time we add a trace, the trace gets added as a new slice in the display. So each slice is full scale. Traditionally on oscilloscopes, all the waveforms would get overlaid, and oftentimes users would adjust the vertical scale and offset to separate the waveforms. And the problem with that is that you sacrifice resolution. So by using this stacked mode, we essentially get a full scale available for each of the channels, and without having the traces overlaid on top of each other. Now at first glance, the probe interface looks like the Tech VPI probe interface that is on the current series of oscilloscopes. But upon closer examination, there's an extra set of connectors down here at the bottom. That leads to some very interesting capability. We call these flex channels. By simply plugging in a logic probe, we can turn a channel into essentially an 8-bit logic analyzer. We put the probe in, turn the channel on, and now I've got those 8 bits that are connected to my microcontroller board being probed by this logic probe. Now, each of the 8 channels on the new 5 Series MSO can either be used as an analog input or a digital logic input just by using the appropriate probe. Now we can see I've added a second logic channel. Channel 4 is being shown down here. So I've got 2 logic channels and the 2 analog channels. Notice that these slices can be resized if you want to change the size of one slice with respect to the other to make it easier to view the waveforms. You certainly can do that. So what we're looking at in this case is the parallel digital input to a R2R digital to analog converter and the analog output of that. So this parallel input corresponds to that analog output, and this digital input here corresponds to that analog output. Now there are a lot of new display features beyond what we've shown here. We've also got the ability to add plots. One of the things we can add is an XY plot. So in this case I'll add XY with channel 1 being the X source, channel 2 being the Y source. If we add that in here, we can actually see what I've created is essentially a graphic. Now of course it's kind of stretched out here, so I'll just simply grab the title bar for that and move that and reposition it. So now I've got all the waveform slices that I showed earlier over here and my new XY plot over there. So let's pause the acquisition here and take a look at some interesting things with cursors. If I add cursors to the display, you'll notice that they appear in the XY display. They're also appearing in the slices in the normal scope view. So if I move those cursors around, we can actually see those cursors moving in each of the displays. So for example, if I look at this location right here, I can see where I am in the XY display. I can actually see the digital value of the bus here for channel 4. If I touch on channel 3, now I'm seeing the digital value for the bus of channel 3 at that location. And I can see the analog voltage for either of those channels as well by simply selecting which channel or which slice I want to go look at. So all of these kind of new features, having up to 8 channels, each of those channels being analog or digital, being able to add plots and move them around and change the way that they're displayed, can really help you to visualize the data in the way that makes it most efficient for you to view and analyze the circuits that you're working on.